Today we'll create this beautiful snow effect using SwiftUI and SpriteKit. To make it more realistic, each snowflake falls at a different speed and it even moves side to side in a sine wave pattern. When a snowflake hits bottom, it slowly fades away as if it were melting. The animation continues endlessly. It's a pretty cool effect. Now let me show you how you can implement it too. All you need is a Mac with the recent macOS and Xcode version. Ready? Let's get started. First, create a new iOS app. Name it Snow. We'll choose SwiftUI for the user interface and the language should be Swift. We need nothing else. Hit Next and save the project somewhere. Next, create a new file called snowscene.swift. This will contain our snow animation logic. Now import SpriteKit so we can use the SKScene and SKShapeNode classes. And now we declare our SnowScene class, which inherits from SKScene. This tells SpriteKit that this class represents a scene in which we can add nodes, update animations, and handle rendering. Inside our class, we'll define two private properties. An SKSprite node that represents our background image. Let's call it background node. And we need a second private property to store our snowflakes. Private var snowflakes. Now, this will be an array, but each snowflake needs three properties: the node itself, fall speed, and wave speed. More on this later. We'll store all these properties in a tuple array. We need a tuple with a node of type SKShapeNode, speed of type CGFloat, and wave speed, also of type CGFloat. And let's initialize our array with an empty array. We need to override the scene.didLoad method. This runs once the scene is loaded into memory. Here we'll set up the background first and create our initial set of snowflakes. I'll name these methods setUpBackground and createSnowflakes. Now these methods do not exist yet, so we get a compiler error. No worries, we'll define the setUpBackground next. I'll make it a private method. And Xcode generates some code for us. Yes, indeed, it's an SKSprite node, and it even guessed the image name, background. So let's add this asset. I prepared it, it's an image I got from the internet. I define a new image set, name it background. And we'll only need a single scale image, and let's add it. Okay, so it's single scale and it's optimized for the iPhone. Cool, now this should be good to go. Let's go back to our snow scene, and actually, after initializing the background node, we'll set its position and it should be placed at the center of the scene. CG point, we'll use this initializer and set it in the middle of the screen. And let's resize it to fit. Background node.size equals the size of our view. Now let's tweak a couple of appearance settings. I'll set its alpha to 0.8. Background node.alpha 0.8. Let's also set its background color to blue and the color blend factor to 0.2. I'll set its Z position to -1 to make sure it appears behind the snowflakes. And finally, we'll add it as a child so it appears in our scene. And that code was already generated. Next, we'll implement the create snowflakes method. Okay, so we got some generated code. Let's keep it, but I'm going to modify it. So instead of 100 snowflakes, let's create more, 200. And to create each snowflake, I'll define a new private method, create snowflake. I'm gonna get rid of this part and let's add the new private method, create snowflake. Responsible for creating a single snowflake. It takes no input parameters and it returns a tuple with the node of type sk shape node, speed of type cg float, and wave speed. And first we pick a random radius in the 2-6 range. That size equals cg float, and it has a random member function, and we can pass in a range, and I'll use the range 2 to 6. I did different experiments with different values, and this looks the best on an iPhone. We'll then create a circle with this random radius using the sk shape node circle of radius initializer. Let snowflake. Awesome. Again, Xcode is smart and guessed what I wanted to write. And even this. Xcode has become pretty intelligent and we got a lot of code completions for free. I love this. So let's keep it and we'll make the necessary changes, if any. Let me see. Line width, well, we don't need that one. Now I want to create the illusion of depth. Thus, I'll make smaller snowflakes look less bright. To achieve this, I'll consider their size when setting their alpha value. Since the size of each snowflake falls within the 2 to 6 range, I will compute the normalized value by subtracting the minimum value from the current size and dividing it by the difference between the two extremes. So we'll get a number between 0 and 1. So let's call this let normalized size. Interesting. Now let me keep my own algorithm. So it's size minus 2 divided by the difference between the maximum and the maximum and the minimum value for size. So that's the normalized size, and I set the alpha value of the sprite in the range 0.3 and 1. Snowflake dot alpha equals almost. So we start from 0.3 plus, yeah, normalized size, exactly, yeah, that's what we need. This will give us values for alpha between 0.3 and 1, which is fully opaque. And let's randomize the snowflakes' movement speeds, both fall and wave. So that's the fall speed. Again, I'll use CG floats random function in the range 0.5 and 2.5. And for the wave speed, which will give our snowflake a nice sine wave-like movement in the horizontal direction to make it more like a real snowflake, it will keep it in between the values 0.5 and 2. Now, before we return these values, we must position the snowflake. I'll define a dedicated method, resetSnowflake. It takes the snowflake as input argument. Let's set the position of the snowflake equals, we need this initializer for x. I'll set a random value in the range 0 and the width of the view. As for the y coordinate, I'll add a random value to the view's height. Size.height plus CG float dot random in, say, 0, 100. We'll call this method whenever a snowflake is created or goes off screen, placing it at a random horizontal coordinate above the top of the scene. Now back to create snowflake, and we can call this new method to position our snowflake, reset snowflake, and finally return the tuple with the node, its speed, and wave speed. We can now complete the implementation of our create snowflakes method. So we'll create each new snowflake using create snowflake. Let snowflake equals create snowflake, then add it to the scene. And finally, let's store it in our snowflakes array. Next, we'll override the scene's update method. Let me scroll down. This method gets called every frame and should be used to perform per frame logic. We loop through each snowflake. And here I'll use our tuple, exactly. And I want to create a soft, wave-like, side-to-side horizontal movement. The sine function is just what we need to achieve this. So I define a new constant, call it wave factor, and use the sine function. I'll factor in the current time multiplied by wave speed, which makes the wave move over time. Then I'll add a slight variation based on height. Snowflakes, I consider the current position, y position multiplied by 0.02. So this adds a slight variation based on height. And finally, I'll multiply the result by 0.8 to reduce the amplitude to 80% of the full wave. And let's add this value to the snowflake's horizontal position. So as said, this will create a soft wave-like horizontal movement. It mimics natural snowfall, I guess. We'll see. Now, the snowflake should move downward. So let's subtract the speed from its y coordinate. Now, if the snowflake goes below the bottom of the screen, I want to mimic a thin layer of melting snow. I'll implement this effect by placing a temporary flake on the ground in the given position. So if the snowflake's y coordinate is below 0, meaning it went below the bottom of the screen, we'll use a different strategy. I'll define a new method, create lingering copy. Just bear with me, it will make sense in a minute. Create lingering copy. It takes the snowflake as input parameter. Let's see how it does its magic. When a flake hits the ground, we make a copy at the bottom, so it lingers briefly. I'll call it lingering flake. Now it takes over the properties of the original, its color, alpha, and position. But the y coordinate needs to be 0 to make it appear at the bottom. I'll add it as a child lingering flake. Then we'll add 3 actions. Wait for 5 seconds. These are SK action instances. Perfect, but let's keep it for 5 seconds. After which it should fade out. Wow, it auto-generates based on the name of the variable I provided. This is awesome. Okay, we don't need ChatGPT to write code. And finally, we'll remove, after it gets faded out, we'll remove through the remove from parent action. Yes, we need the sequence, no typing required, and we run our sequence. All this code was generated by Xcode. Thanks so much. Now, calling this new method from update will give the melting effect. Create lingering copy of snowflake. Now, how about the original snowflake? We'll recycle it by resetting it back on top using our reset snowflake method. Our snow scene class is almost ready. We must do some cleanup though. You probably noticed all these magic values sprinkled throughout the code. 5.0 here, 0.8 there, and all these ranges and other values. I really do not like such code. It makes our code not only look sloppy, but also harder to maintain. If you decided to tweak them, like changing the snowflake count or the fade out duration, you have to go searching. So let's place them into a dedicated constants enum. I did this exercise earlier, so I'll just copy it here. Now we have all our class-specific constants in a single place. The constant names make it obvious what these numbers represent and why they are needed. This makes it easier to tweak everything and instantly makes the code more readable. And finally, let's replace all the magic numbers in the snow scene code with the corresponding constant values. And we're almost done. Let's switch over to our content view and add a few lines of code to complete our implementation. First, I'll import SpriteKit. Next, we'll define a computed property called scene. And initialize it using our snow scene with the size of the screen. Okay, so it should be a computed property of type skScene. And now we can set its scale mode scene.scale mode fill, and we can return it. Then we need to replace the body's implementation with SpriteView scene. So I'm gonna remove this code and I'll instantiate a sprite view. With our scene. Looks good. One more tweak though. Let's expand our view into the safe areas to cover the entire screen by calling ignores safe area. Now it looks exactly like the demo I showed you at the beginning. Awesome. How about building a replica of the Apple Watch activity rings next? Check it out in this video here.